Okay, here we are again. I'm going to see about doing a little gasoline direct injection quickie. Anytime I talk about newer technology, I like to run through some of the old stuff that led up to it. And a lot of the times I used to work on these old updraft carburetors that were on tractors and stuff, and they're pretty cool. Zenith was the brand name of most of them. They're also, some of the European cars had side draft carburetors on them, but most of the ones that we've been used to in this country actually pull the air in through the top. And what it basically did, you had this little, anybody that knows anything about a carburetor knows this, but I'm going to cover it anyway. And we had a little jet down there, and it was actually coming up here so that whenever air came through there and it went through this little narrow area of the carburetor, it made a low pressure area that drew that fuel out of that jet. You know, I used to change the size of jets and carburetors playing around just to see what it would do. You know, but anyway, here they came, and it would mist that gas down past the throttle plate. Now, when the throttle plate was closed, the gas that it was running off of wasn't coming through here. It was going past the idle mixture screw. But this is not really going to be a show about carburetors, although I'm touching on them a little bit. I got a pretty good few slides. This is a variable Venturi carburetor. I read somewhere on a something I was reading one time that this carburetor was actually designed by Hitachi. I don't know about that, to be perfectly honest. I can't speak with authority on that, and I don't know if the whoever it was that wrote the article was sure about that. They just mentioned it in passing. They didn't go in detail about it. But I worked on these carburetors up until 1991. A lot of the police cars that had 5.8 liter engines had these variable Venturi carburetors on them. And the issue with that was there was a big vacuum diaphragm back at the back that opened that Venturi. When it pulled this back, it would basically, the metering rods in carburetors are peculiar anyway because they're tapered, and whenever the big part of the metering rod was in the jet, not a lot of fuel could come through. But as you pulled it so that the narrow part of the rod was in the jet, more fuel could go around that rod and past the jet and all that. And these carburetors weren't really all that complicated, but you needed to understand how they worked. There was a little bit of an adjustment back here you could make on the movement of that diaphragm, and also this diaphragm back here liked to bust on these things. But this is basically what it looked like whenever the throttle was closed. But then whenever you open the throttle part way, you can see the plate down here. That was off idle, they call it. In other words, if it's not idling, but it's not really cruising either. It's just up a little bit, give it a little bit of gas off of the idle position. It pulls a little more fuel. And then this right here is part throttle cruise. It's basically letting this little slider lets more come back. And you might also notice too that what's moving that is that diaphragm back there. See how that diaphragm changed in position? And then finally your wide open throttle. Let me back up for a second to that first slide that I was talking about. This one here, I want you to pay attention. If you can see it, you see that little dotted line? That right there is a vacuum feed to behind this diaphragm, is what it is. And basically, or pressure feed or whatever. Long and the short of it is it would move that diaphragm this way, would pull air back here, and the farther it pulled it back, the more this pulled back, the narrower that it came, and the more it pulled gas and went in there. Like I say, it was fairly simple. Now they did have a version of it that had some electronics connected to it and all of that. But I'm not going to spend a lot of time on variable Venturi carburetor. But I will say that some of these police cars that were brand new, whenever they put the carburetor on there, when you went to wide open throttle, they would not open that wide open. Because they didn't have enough vacuum to do it. And so what I would do is I would do a little bit of work with my pliers and everything and bending those little tangs so that when you went to wide open, you would be mechanically opening this. And I had one police officer that told me that when I made those adjustments so that it would pull that thing wide open when he was at wide open throttle, it gave him another 40 miles an hour on top end. He was complaining. He says if you're chasing a Toyota out in the country with one of these, the way it was set up when it was first built, you would lose him if he made a lot of turns because you didn't have a lot of throttle to catch up with him. Anyway, that's pretty interesting. Well, then they went to this throttle body fuel injection. There was a lot of vehicles that had that on it. This was the kind I was really familiar with. There was a single injector version of it with a little pod style injector in Tempos and Escorts that we worked on now and again. And this thing right here had 40 pounds of fuel pressure on it. Now the 4-cylinder Taurus had a little single pod fuel injector to it, but it ran a higher fuel pressure than the Tempos and the Escorts did. Anyway, this one had 40 psi. It didn't have a vacuum line hooked into the fuel pressure regulator because it didn't need to, because the injectors were above the throttle plates. You could actually watch them work, you know. Now this one right here is your GM that everybody was so familiar with. They usually had about 13 to 15 pounds of pressure. When the fuel filter would stop up on one of these, it feels like the exhaust is clogged. Whenever you're really getting into this, it's just dead. It doesn't feel like, you know, normally when on a carburetor, for example, when you're standing on it trying to go somewhere and your fuel filter's clogged up, it starts out good and then it sort of dies back when it runs out of fuel. These felt totally different from any other unit I ever found. I had seen some of them that would have, you know, they would still run even with 2 or 3 pounds of fuel pressure, but they didn't run good. Then you had your Chrysler one that had these fuel injectors in here. The funny thing about those is the little ball that would work in the bottom of the injector that would, that would be lifted off of there to let the fuel out would get pitted. And so they would let a bunch of extra fuel out of there that wasn't supposed to come out, and they would start to run rich. Well, the mechanics back in those days in the Dodge dealerships, apparently a lot of them weren't aware of adaptive learning in fuel trim. You know, fuel trim, before it was fuel trim back on the old cars, used to be called block learn and integrator. Integrator would be your short fuel trim and block learn would be your long fuel trim. They changed the name of it, you know, with OBD2 and all that. But integrator had been around for a very long time. One way or another, there was a recall because of some of these injectors getting pitted balls down there on their pedal, and these mechanics wouldn't pull the battery cable off or anything. They just change out the injector under the recall, and when they did that, because it was accustomed to that extra fuel and they had learned it, it would run really terrible, and the mechanics would get angry because they weren't getting paid much of anything to change these injectors anyway. And some of them would put the old injector back in there and put the thing out and mark that they had done the recall, you know. And it was really annoying whenever they didn't tell us about, that was happening at the Chrysler dealers. I heard about that at a Chrysler school that I went to in Atlanta when I was learning about something else and somebody brought it up. But anyway, now this right here, this particular version, this is a photo of the Ford V8, and it used 40 psi, and they had a little Schrader valve right here where you can check it. I love it when they got a Schrader valve to check the fuel pressure. Now these other ones back here, they didn't have a Schrader valve. You'd have to hook something up in line between the fuel filter and the throttle body or whatever. It was real aggravating to check the pressure and all that. But I mean, eventually they started taking the fuel pressure check ports away from us on some of the multi-port. Now, one time I helped a guy over at the Ford place whenever we also had the Jeep franchise, and one of the big boss men had a Jeep that had a carburetor on it. It was just a continual problem, and he was gonna he wanted to not have to deal with carburation issues anymore, and the thing running bad when it was cold and all that sort of stuff, and blowing black soot on the wall of his garage when he fired it up, you know. And so this $1,000 kit here, and one similar to it, we managed to put on that Jeep, and it was a V8. It was one of those Jeep, I think it had a 340 in it or something. I can't remember what size motor that was, but it was one of them V8 Jeep Wranglers. That was an older one, late 70s as I remember. And we put that fuel injection kit on there, and that thing ran so doggone good. You know, if you've got one that you're fighting with a carburetor all the time, you got a little spare cash you want to drop on it, you might throw one of these fuel injection kits on it, and you might be surprised how good it'll run. The guy that's the president of the college, or he used to be, had this Cadillac, this 71 Cadillac I've featured in a few videos, and I suggested that he get an electronic ignition kit and put on his Cadillac, and he went ahead and did that. And he said it was amazing how much better that car ran, and how incredibly much better it started and everything else. with that little electronic ignition kit that he put in the distributor. Anyway, this CSFI, I couldn't really go through fuel injection without talking about that. You remember these little poppets, you know, that went into each cylinder, and each poppet had its own little solenoid that operated it separately. But the screwy thing about those, with those poppets, they had to have a certain amount of fuel pressure to even work. And sometimes you would get a vehicle that wouldn't start, and you check the fuel pressure, and it'd have like 58 pounds of fuel pressure, or 56 pounds. But if it didn't have 60 or 61 pounds, it wouldn't even start. And that's very confusing if you weren't familiar with those things. All right, they had, and I put, my dad had a 96 pickup with a V8 in it, and I put this kit right here, this electronic kit, which even the dealerships are putting these electronic fuel injection kits on there. And you can't even tell when you've put that on there from looking at the engine that that's what's in there. But they basically have some little injectors they put down here, and the same wires that operated the solenoids for each one of these poppets operated those. Now the issue with these is when somebody pulled the distributor out, like if they were playing an oil, or doing an oil leak, I'd hear about this. I had an oil leak fixed on my Tahoe or whatever it was that had one of these in it, and after they put it back together, the gas mileage went from 22 to 14. Well, the reason it would do that is because the shop a lot of times would put it back on, and I've talked on here before about cam retard offset and how you have to set that on one of these, which means you put the distributor in there and you get it set. The cam sensor in that distributor has got to be timed properly. Get above 1,000 RPM with the cam retard offset pulled up on a scan tool that has that, and not all of them had it. I've even seen scan tools that had cam retard offset, and then you'd get a software update and they'd take it away from you. I don't know why they did that. Long and the short of it, you get that cam retard offset set around right real close to zero by turning the distributor with the engine above 1,000 RPM. When you get that set right, then everything is going to be better. If that cam sensor is out enough, this thing will just bank fire these injectors. And when it bank fires the injectors, it makes terrible fuel economy rather than sequentially firing them. Now this right here was bank fired injectors on some of the Fords, and they weren't always configured exactly like this. Some of the Fords that I would see would have these two and these two and those two and those two as their two separate banks. They were bank fired by pins 58 and 59 out of the engine controllers, a little 60 pin thing. But then they went to these sequential ones. Now the first sequential ones I knew about in the Ford line was the Crown Victoria. They had sequential fuel injection. Tempo went from bank fired to sequential in 1992, and whenever they did that, they added a cam sensor and changed the little cup in the distributor so it no longer had signature PIP. And you might remember a story I told about the body shop had replaced a distributor in a 92 or a 93. It wasn't an Escort, it was a Tempo. And that Tempo was dropping cylinder number 3 because they put a distributor in there with signature PIP. It didn't expect that, and it would stop firing the cylinder number 3 spark plug whenever the timing advanced. But if it's got a cam sensor on those 92 because it was sequential electronic fuel injection, one way or another, this is the way that fuel injection went. Now, fuel injection droplet sizes from carburetors range between 50 and 200 microns. A micron is a millionth of a meter. It takes 1,000 microns to make a millimeter. Okay, but by and large, MPI is only slightly better than carburetors, but sequential fuel injection with higher pressures would help some, and it it made them run better and get better, slightly better fuel economy and all that. My wife's pickup truck is not gasoline direct injection. It's an 06 F-150. I'm sorry, 16 F-150. I got an 07 F-150 that gets about 17 miles to the gallon with a 4.2 in it. Her little V6 3.5 gets 27, 28 on the highway. Now her truck's 800 pounds lighter than mine. That's got a lot to do, or 700 pounds, whatever I looked it up. That's got a lot to do with why she gets so much better fuel economy. But she's also got variable cam timing, and this kind of thing. And it's a slightly smaller engine than mine. But automakers kept working on getting fuel economy better and better and better. And that car, that truck, it's not an EcoBoost, it's just a plain old 3.5, and Even though it's not an EcoBoost, it will really scoot if you need to get into traffic because it's got that fancy variable valve timing. That 3.5 is a very, very similar engine to the old 3-liter Duratec that used to be in some of your Tauruses and stuff. Anyway, if you've got faster airflow, you're going to have smaller droplets. If you've got hotter fuel, you're going to have smaller droplets. Higher pressure, smaller droplets. Smaller orifice, smaller droplets. There's all kinds of stuff they do to make these droplets as little as possible. Now this is something that I'm going to tell you guys about. I didn't draw the full plans for this thing because there's a lot more to it than I'm showing you here. I mean, I had the full plans one time long years ago, and there's a lot more to it than I'm showing you here. But somebody back in the 1930s came up with this funky homemade carburetor deal, and what they would do is they had it where they would run a copper pipe from the exhaust, and it would curl around inside this can, and then it would go back out. And you know, I put it with it turned that way so that as the air was going past it, it would draw the exhaust that was going in here through there. And as that copper pipe got really, really, really hot, and you energized this, I mean, you actually changed your valving so that the fuel pump was pumping fuel through some little jets, that it was squirting all over those copper pipes. It would turn that gasoline into steam, and then you were pulling air in right here to carry that steam into a little pipe that was going through a lawnmower carburetor in there. You had already you had some valving to shut the fuel off that was going to the carburetor, so the carburetor was running dry, the regular carburetor, and you had to get it good and warm for this one to kick in. And this right here, this carburetor, like I say, don't try this at home, because if you make one of these things and it blows up under the hood of your car, you're going to be in big trouble. I'm not saying this is a good thing to do, but this guy built this thing and got it to work, and it was 100 mile to the gallon carburetor. But I heard somebody say that the oil companies bought the patent so he couldn't sell these things because they wanted cars to burn more gas. That's another reason they quit for a while. For about 10 years they quit putting overdrive on vehicles, because overdrive made them get better fuel economy. They went back to overdrive. From 69 to 79 they almost didn't have any overdrive of any kind. But starting in about 1978 or 79, they started putting overdrive transmissions back in there. Only it wasn't as complicated as the previous overdrives. Anyway, on MPI, the fuel charge is briefly stored behind the intake valve until it opens, but it's just a real brief amount of time. And then whenever the intake valves open, the rush of air coming in from the intake, because you got low pressure, because you basically have got this piston going down making this bigger. You know how when you put a straw in your mouth and you make your mouth bigger on the inside, the atmospheric pressure pushes the drink up the straw and into your mouth. Anyway, this going in here, this fuel would get carried in by the incoming air, then the valve would close, it would squeeze it, and then it fires, and so on and so forth. Now this right here is the difference. That's the Earth, and that is one of the moons of Mars, I think. But GDI atomization, MPI droplet, GDI droplet. That right there is the difference in the size of those droplets. And it's obvious that the smaller the droplet, the better and more complete the combustion. You know, and this thing I was showing earlier, this homemade carburetor project that I didn't give you the complete plans for, makes steam. And that gasoline, if it's just pure steam, that's really, really, really small. And I actually knew a guy down in Louisiana that built one of those and put on his pickup and got it to work. I never tried to build one, you know, because I always had the idea if it backfired through there, I'd have a bomb under the hood, and I didn't want that. But anyway, there's a couple of different ways that they configure these GDI injectors. The gasoline direct injector is going to either come right in here in the middle. Sometimes it'll be a beautifully set up thing right in the middle between the valves and all that kind of stuff. Sometimes it'll be slightly to the side, but this is in the center. This is that wide spacing it comes in, and when that gasoline is sprayed in there, it basically cools the metal a little bit. So it's got a cooling effect, especially if it's running with a stratified charge. GDI works better because fuel is delivered and has to wait for the intake valve to open on MPI. On GDI, it can be delivered when and how the engine controller wants to put it in there. It can squirt it in there for a homogeneous mix, or it can spray it in there. It can start the fire and then add some more. How many of you guys are familiar with split shot injection on diesels? Remember how in California they went to that on the old Power Strokes. They built some injectors that had a mechanical split shot function so that it would start spraying fuel, and when the fire had already started it would add more fuel in there, and that helped some with emissions and noise and other things. And then now when the 6-liter came out, they had a split shot function that was fully electronic, because the injectors on a 6-liter have got a couple of solenoids that move a spool valve, and it opens and closes it. And those would have a little bit of an idle hunting thing, and then so forth. Says, well, we'll do away with the split shot. When they did away with the split shot, the fuel economy on those 6-liters went from 18 down to 13, and made everybody mad. Even so, the 6-liters are the favorite of a lot of the people that do Power Stroke, but they like the 7.3s better. More injection choices means a cleaner burn, more power, smaller engine. You might notice some of these minivans and all have got little bitty engines in them, like 1.6 liter engines, and they got gasoline direct injection in there. They still got a pretty good bit of power. Alright, and so stratified injection heats the catalyst. It's not for power. It puts a shot in there, and then it puts another shot in there after it's burning, and it runs really, really hot. They don't typically use this for loads because it makes more NOx, and you don't really want to make a lot of NOx. As if they could, if NOx wasn't an issue, they could do that. Homogeneous injection is the full burn just for power, like when you're pulling a load or driving hard down the road. And then there's mixes of the two strategies, like for anti-knock, like if you've got pinion or something like that. There's ways you can do that. So intake valve deposits are an issue, but some automakers have just added MPI injectors to the GDI system to help spray and wash the carbon off. Ford, Toyota, Hyundai, some of the others are going in that direction. Now the strategies of how they operate these injectors are different. They don't all operate the same way. Like if I remember right, Toyota operates theirs all the time. Ford only operates their MPI. In other words, some of them shut off the GDI injectors and just run on the MPI injectors at low speeds, but when you got full power, they all work together, and there's a bunch of different ways they operate. I'm not going to go into all of that today. This is just a quick primer anyway. Intake valve deposits don't just happen on a GDI vehicle. How many of you guys have seen these top tier gasoline ads that show clean valves and dirty valves? There was a time back in the in the 70s, they were due to emission controls and lean fuel mixtures, but in the 70s and 80s, they had gas was really changing up with fuel injection and all. One of the things that they failed to do when they were making gas in the 80s and fuel injection with the high pressure pumps became prevalent is they had to put lubrication in the fuel. You might notice, if you ever remember getting gas on your hand from back in the day, like from the late 70s, it would dry your hands out some fierce. But if you get gas on your hands now and you wait till it dries, you feel greasy stuff on your hands, which is the lubrication for the fuel pump. I don't know how many fuel pumps I had to replace that were making a lot of noise, and whenever they'd get hot, they'd make a bunch of air bubbles and cavitate and all that nonsense. Well, whenever they started putting that lubricant in the fuel, they stopped having that problem. Well, they started doing these olefins, these diolefins that we were told about. I don't know if you could see those or not, but one of the things that used to trouble me was I would get one of those white plastic drinking cups, like you got a big, not a styrofoam one because the gas would go right on through it, but one of those white plastic ones. Back in the 80s when we were having a lot of issues, and I would get some of the gas out of the tank, even from the filtered side, between the filter and the engine, and I would leave it sitting there, and you would see a lot of little black specks and particles in the bottom of that. And I couldn't really figure, a couple of times I cleaned the gas tanks on that, but that nothing seemed to help. The next time you looked, you still see them black particles in there, even after cleaning the tank and having a new fuel filter with a new fuel pump. I don't know if that was the olefins or what it was, but I do know that those olefins were supposed to go through there and keep the injectors clean, but they would get trapped when the injector closed, and they would build up on the injector panel, and they would cause the problem they were trying to prevent. Furthermore, they would pile up on the valves. And when they piled up on the valves, you would have the same kind of problem and the same kind of stumbles and the same kind of hogwash largely that you're having with GDI engines, which don't have the MPI spraying on there to keep the valve clean. You know, of course, the quality of the fuel, oil changes, there's all kinds of stuff that brings that to pass. But anyway, we used to have to get in there with a carbon blaster with a walnut hose, get in there with a walnut hole blaster, and we had a little thing we put walnut hole media in, a little hose plumber. We would look with a borescope through the spark plug hole when the valve was open and see if it had a lot of those deposits. If it did, we would pull the upper intake off, and we would pull the fuel rail out, and we'd go in through we'd put a vacuum attachment on the intake and get that thing sucking on the intake really, really good. It was like an air vacuum attachment. You hook up to your air hose it'd blow up this bag with air that was being pulled out of the intake. Then you would do your walnut hole blasting around that valve and look in there with your Olympus borescope again, and once you got it clean, you know it was clean as a whistle. But while you're doing that, all those walnut holes were working their way into that bag and carrying all the trash out of there. Occasionally there'd be a few walnut holes that would be laying around in the intake, and they might get trapped under the valves, and it'd skip a little bit, and you smell walnut holes burning, but it didn't really hurt anything. And so what we would do, after we cleaned those valves with walnut holes, those vehicles would run like a spotted ape. I mean, they were like brand new. And but before we figured all that out, we fought tooth and nail against all these carbon deposits that were building up on valves, particularly in four-cylinder Rangers, but it could happen in Tauruses, and it was just a nasty mess. Jeep Cherokees had that problem. And Jeep, in their infinite wisdom, they decided, and this was back when they were still using those bulletproof Bendix engine controllers, you remember, that were mounted up above the gas pedal, before they Chryslerized the darn thing and put the thing out there under the hood. Anyway, that Bendix fuel, what they did was they said, well, this olefin stuff, the stuff that it crusts on these valves, has a tendency to absorb octane really well, so when it was cold it would stumble and fall on its face because of all of that olefin deposits. And so what they did was they rewrote the algorithm apparently so that when you first started it, it would saturate those deposits to the point to where you already had got past the point where they were saturated and you didn't have the stumble. And that was a $600 repair if you had to buy one of those engine controllers. And so what I did was I devised a way to use the carbon, I don't want to keep saying carbon blast, the walnut hole blaster on the Jeeps. I actually devised a way to make that work, and I started fixing a lot of those Jeeps by blasting the valves with walnut holes, and it worked really, really well. And you can also clean the valve, the deposits off of these GDI. You got to pull the upper intake off so that you've exposed the valve so you can see them. Some people scratch the stuff out of there and they wash it out with chemicals and all that stuff. But some people get a walnut hole blaster and a big strong shop vac and hold it right there while they're doing it. You need to do it with the valve closed so you don't wind up getting a bunch of walnut holes down in there and locking something because you got stuff on the other piston. So always do the valve cleaning with the valve closed. We had to do that on those trucks in the 80s too. But anyway, I wound up with me a whole bunch of those Bendix engine controllers because it was kind of funny. This guy came one time to the parts room. He wanted to buy an engine controller, and he didn't know it was going to be $600. And they told him, they said, well, Richard has a bunch of those out there and he may sell you one. I didn't care if I sold one or not, but the parts department sent the guy out there to see if I'd sell him one. So the guy comes out there and he goes, hey, I want to buy one of those engine controllers you got because I need one for my Jeep. How much you take for it? I said, $125. Just pulled a number out of the air, and he goes, would you take $100 for it? I said, $135. He says, good grief, you're going the wrong way. Would you take $90 for it? I said, $145. He said, I'll give you $125. I said, all right, that sounds good. So I sold him one. But I wouldn't sell a customer parts unless the parts people sent him out there to see me, though, But anyway, long and the short of it is, on these GDI systems, you got a low pressure pump in the tank, and it's feeding, probably less than 100 pounds of pressure, usually 60, 80, whatever, up to this line. It goes to this little high pressure pump. That high pressure pump is driven by the camshaft, which mechanical pumps, even on common rail diesels, are driven by gears or the camshaft. Some of these are driven by chains and gears and stuff like that. And basically it's getting you know, 500 to 3,000 pounds of pressure or more that it's going through these little these injectors here. And it's basically on the fuel rail. It's got a fuel rail pressure sensor so that it can basically get feedback, and it uses a solenoid on the pump to control the pressure in the fuel rail. Now there's a lot more to this than I'm telling you. I'm just giving you a quick primer on it. You got this high pressure pump, mechanically driven, electrically controlled through this solenoid, and it's a closed loop system because what closes the loop again is the high pressure fuel rail sensor. You know, if you're familiar with common rail diesels, you're going to have this, you know, wrapped up as far as that way that system goes. High pressure injectors, low pressure pump, in tank electric. Now some systems have got a closed loop low fuel pressure system which got a low fuel pressure sensor on it and a fuel pump control module that provides the right amount of current to the low pressure pump to provide that. Now let me say the low pressure pump, if the high pressure pump is disabled because somebody's unplugged the solenoid on a normally open version of it, the low pressure pump can push enough fuel through that high pressure pump that the engine will run, but usually it will barely pull your hat off. It'll idle, you might be able to rev it up a little, but it won't have any power running with just 80 pounds of pressure in that fuel rail because of the way the injector is set up. But some, like Hondas and early Hyundai Sonatas, have a plain old relay and an in-tank regulator for their low pressure pump. They don't have a feedback loop for the low pressure so they can control it with the engine controller. They just let it, that open loop low pressure system feeds pressure to the high pressure pump, and it takes it from there. To pressurize the fuel system, some GDI vehicles, whenever you open the door, they'll run the pump for a little bit to pressure the system up. And some of them, some of the Chevys, whenever you shut it off, you may walk away and you may be walking by the car 10, 12 minutes later and you may hear the pump go wing, the low pressure pump. It can't run the high pressure pump unless the engine running. Alright, so the high pressure pump has a piston that's driven by this cam. Usually there's 3 lobes on the cam, but there can be more than that. And like I say, some of the pumps, like on some of the BMWs, it's basically driven through the vacuum pump, believe it or not. But that's another story. Camshaft and a solenoid that controls high pressure pump output. There's your solenoid, and there's a couple of different kinds. Most of them default to low pressure when you electrically disconnect this. Don't ever use power and a ground to test this thing, because if you do, you'll burn it up. Just like the injectors on these, they've got almost no resistance whatsoever, and you will burn them up. Now that's on the copper coil, and there will be fried, and you're going to be in a mess. But most of them default to low pressure. In other words, the pressure goes completely away when you unplug that. But there are a few up for like 2011 through 2016 in some of the Chevys. When you unplug it and start it up, the pressure will default to high, and it'll buck and snort and act like it's got cross plug wires or something. And so anyway, that's but they all are going to operate very similar to this. Now, if the oil hadn't been changed the way it should, or if something's going on, like if the oil's been diluted with fuel, it really begins to wear this out really, really fast, because there's a tremendous amount of pressure there. And you better pay attention to that oil change interval. And on a lot of these, you cannot believe what your oil change reminder is telling you. You better go by the miles. Make sure you use exactly the right kind of oil. Don't substitute anything. Put the right amount in there. Keep the dipstick pulled regularly to see if it's getting some extra oil in there, because if it is, you may have fuel leaking out of the pump right here down into the crankcase. The injectors are exposed to combustion heat, so they have long nozzles for cooling. And they got these Teflon seals to keep compression from blowing back up in there. But the tip of that injector is exposed to that 2,000 plus degrees combustion heat. And that is a pretty robust little thing. And sometimes they'll, crud gets in that injector, and it gets, particles of carbon in it, and it starts to leak and all that. Buy the special tools if you're going to replace injectors. Don't try to get those things out of there with a pry bar or something, because a lot of times you'll bust something and you'll wind up in a lot worse shape. So get you the tools. Now the tools aren't the same for every injector either. It's really peculiar, because Volkswagen and Ford and Volvo, I think, use slide hammers to jerk them out of there. General Motors has these little hooks that you put on there, and you tighten these screws to pull them out. BMW and them have got a special little deal that you a little T-shaped thing you put in there and you bolt it down, and you basically turn these left-handed thread nuts to extract them out of there and put them back in. But if you don't do it right, and if you don't replace those Teflon seals every single time you have one out of there with a new Teflon seal, which you got to put in on over there, anybody that's done transmission work on 700R4 or one of those where you have to put those Teflon seals on there and size them, it's very similar to that. And engine oil contaminated with fuel is a known issue. There's three reasons, primary reasons, there may be other ones that can happen. Frequent short drives will do it, even if nothing else is wrong. Leaking injectors can let fuel go down there and drip past the rings into the oil. Leaking high pressure pump, that's just three of your main ones. This is not an exhaustive list. All right, another one, intake valve deposits. You got rough running, misfires, hard starting, poor fuel economy, bad cold starting, cop coil failures, other symptoms. Leaking injectors, you can have intermittent misfires, sooty spark plugs, fuel seen dripping through the spark plug hole. In other words, if you got a misfire on one cylinder, if you pull all the plugs out and you shine a bright light down in there and you turn on the low pressure fuel pump so that it pushes the fuel through the high pressure fuel pump, if you see fuel dripping in any of those holes, you got injector issues on that one. It's a good idea to go ahead and change all the injectors, and cleaning the injectors doesn't work worth a crap on these. So, you know, get that out of your mind. You can try it if you want to. But it's a good idea to set your customer up with a intake valve cleaning, you know, with pulling your intake and doing this, you know, however you decide to clean them about every 15, 20,000 miles and all that. Pressure loss during hot soak can be caused by fuel leaks in the fuel line fittings. If you take a fuel line fitting loose because that fuel line fitting has got a soft iron ball in it, when it seats against that hard iron rail, it ain't going it's not going to seal when you put it back on there. You've got to put a new fuel line back on there if you've ever taken a wrench and broken loose. Don't do that unless you got a new fuel a new fuel line to put back on there. A lot of the times when you buy a replacement high pressure pump, it will come with a replacement fuel line. On your the high pressure fuel rail pressure sensor is what I'm trying to say. It's also got a soft iron seat. This is not new. Duramax, Duramax, the Chevrolet Duramax, on their fuel rail pressure sensor, it had a soft iron seat, and you can only use that one once. If you took it off, you couldn't put it back on. You had to put a new one back on there. And so keep that in mind. Anything you take loose from that high pressure side, as far as the lines or that sensor, has got to be replaced. Low or insufficient pressure is, you know, a known issue. Worn high pressure pump can cause that, because of, you know, if it's worn out on the bottom and the stroke is shorter than it should be, you'll have issues with that. If you got electrical issues with the pump solenoid, it'll cause that. This is just a quick rundown. There's the high pressure pump on that one. Just a big picture view, and so be aware that this was just a quick run through gasoline direct injection. There's a whole lot more you're going to need to know before you start tinkering with these things. So don't get on over your head by thinking you know more than you do. Well, I appreciate you guys coming by, and I hope you got something out of this. Let me know if you did. You know, give me a like or hit the bell, you know, that kind of stuff. And I need all the subscribers I can get. You know how that goes. Talk to you later.